so nice to have you here with us. This is now our fifth lesson on trigonometry, although we didn't start exactly where we wanted to, because you had to do some lessons with Marilise as well. So just a reminder that we are differentiating these lessons. What we're going to be doing in this course is going to be slightly more difficult than in the other course. So yeah, I've chosen some questions tonight that are hopefully going to challenge you, and we'll get to those in due course. Just a reminder that everything that we're doing at the moment in trig, we're not allowed to use calculators. If we want to use a calculator to like work out the answer from something like Pythagoras or whatever, that's okay, but we can't just pick up a calculator and work out the answer. And besides which, in this particular section, this particular topic, a calculator is not really going to help us anyway. So I've put the compound angle formulae there for us, and I've put the double angle formulae there for us as well. Remember, when you are answering questions in tests and exams, these will be provided to you, but if you do learn them off by heart, just make sure that you've learned them correctly. And if you copy them, make sure you copy them correctly. The number of matrics who don't copy these down correctly is actually quite staggering. So yeah, just make sure that you're copying carefully, because if you don't, then things are never going to work out. All right, so ratio in terms of a letter is a concept that is closely linked to what we were talking about on Thursday, to Pythagoras. The difference is, though, well, first of all, you're working with a ratio in terms of a letter rather than a particular angle on the Cartesian plane. And because you're going to be working with a particular letter, what we also do is we only work in terms of acute angles. So when you are doing ratio in terms of a letter, unlike with Pythagoras, you don't first have to decide which quadrant you are working in. Right, because all of these are acute angles. The presumption is when we do ratio in terms of a letter, we are always working in quadrant number 1. Okay, so that's the first thing. Also, whether the question tells you to or not, you are supposed to draw a diagram, but you can get around that if you use the Pythagoras identity in order to be able to work something out. But I just think that the diagrams are a nice way of being able to represent what it is that we're trying to do. Okay, so let's jump into it. The first example that I have chosen for you is if the cos of 25, this is example 11 that you can see in the middle of the screen. So if the cos of 25 degrees is equal to k, there's our letter, determine the following in terms of k. All right, so all of our answers need to have k's in them. All right, so we're not working out the value of k. The value of k is unimportant in this situation. We're going to be working in terms of k. All right, so starting place, let's draw ourselves a diagram and then let's analyze the information that they have given us. Okay, so here is a y-axis badly drawn by me. There's an x-axis. Remember, our terminal arm is anchored at the origin. It's now swung 25 degrees in an anti-clockwise direction, and it's come to rest over here, and it makes a right angle with the x-axis. Okay. Next thing that we need to do is analyze the information that's been given to us. The cos of 25 is k. So we all know that the cos of any angle, okay, is x over r. All right, so what they are telling you here, matrix, is that for the purposes of this question, your x coordinate is called k. We do not know what the y coordinate is. We can't calculate or determine y from cos theta. And the other thing that they are telling us is that r is equal to 1. K means k over 1. Okay, so the length of the terminal arm is 1. R is equal to 1. So that's from this point here to the end point. And at the end point there's an x and y coordinate. We know what the x coordinate is, it's k. It's now our job to work out what the y coordinate is. How do we do this? We have to use The theorem of Pythagoras.
Pythagoras.
Okay, Pythagoras, quite right. So we go x squared plus y squared equals r squared. All right, remember we are solving for y. We want y in terms of k. So we're going to leave y squared on the left-hand side. We're going to take k squared over to the right. 1 squared is 1. Change the sign of k squared to a minus. And now we're going to have to take the square root. Now, previously when we were doing questions on Pythagoras, we needed to be careful when solving for x or y because x and y change sign depending which quadrant we're in. But we are working in quadrant 1 because this is ratio in terms of a letter. So that means that our y coordinate is going to be positive. So y is equal to positive 1 minus k squared. Now, a lot of matrics go wrong here, right? In a number of different ways. First of all, they get the k squared and the 1 muddled up, and it ends up being k squared minus 1, when in fact it's 1 minus k squared, and that's not the same thing. And the other thing that also sometimes happens is that the square disappears off the k. So sometimes, and this is incorrect, I don't want you to write this down. Sometimes what happens is that we see this, y equals root 1 minus k. Now, why is this wrong? Why can I not say this? This is wrong. Why can I not do this? What's wrong? Does anybody know?
I think it's wrong because when we do Pythagoras theorem, it's squared of everything. So the k is supposed to have a square. That's why I think.
You're on the right track. Absolutely. Yes. Who's talking?
It's me, Tando. Is the purpose of the square root to cancel out the 2? So if you get rid of the 2 before applying the square root, it doesn't give us the conclusion.
Absolutely, it doesn't give us the correct conclusion. And what this basically comes from, I'll just do a little quick thing here on the side so you can understand where this comes from, all right? It's the same thing as what you were exposed to way back in grade 8, all right? So the idea is this: if I have a square root and I have something minus something else, let's take numbers. So let's say I've got 100 minus 64. Can I say that it's okay for me to say that this is the same as, let me just make that a little bit shorter, sorry, that it's okay for me to do this? Because if you drop the square off the k, that's essentially what you're doing. You're square rooting the first term and you're square rooting the second term, right? Am I allowed to do this? Will it give me the same answer? Okay, and the answer to that is a big fat resounding no. Okay, it's not okay, it's not the same thing. Because if we continue doing this like this, we should take 64 away from 100, which gives us 36, and the square root is 6. If we do it this way, which is incorrect, we get 10 minus 8, which is 2. Okay, 2 and 6 are not the same. Okay, so just very, very important. I'm just giving you these little tips along the way that are going to make the world of difference for you in terms of your accuracy marks. Okay, so be very careful. You cannot just magically drop the square off the letter. Okay, so be careful of that. What I like to do, similar to Pythagoras, is that once I've worked out what the value of my missing either x or y or r is, I like to go and put it together with the others so that I know what I'm dealing with. So over here, I'm going to write root 1 minus k squared. And now I'm going to be focusing my attention on this purple block over here, because that is how I'm going to get all my answers in terms of k. So I had to do all this work first before I can actually get started on the question. All right, so I suggest you do that, and then you can refer back to it and you can answer anything that they give you. Now, because you are in matric, you have to expect that they are going to give you compound angles and double angles. So be looking out for these things. I mean, they may give you something straightforward as well, like a reduction formula from grade 11, but be on the lookout for compound angles and double angles. You have to expect them. This is part of the syllabus now. These are the sorts of things that they're going to be testing. All right. So you are going to look at number 1, and they've given us the cos of 155. So the moment they give us an angle that is not acute, the first thing that we want to do is apply our grade 11 reduction formulae and reduce that angle. Okay, so 155 is sitting in which quadrant? Which quadrant am I in? Quadrant 2, absolutely. And that means that when I reduce cos 155, it's going to be positive or negative. Exactly, can you see? It's going to be negative. So it's very important that we write what we get when we've applied a reduction formula. So you must write, you have to write here that this reduces to negative cos 25. You're going to get a mark for that matrix. You have to write it. Okay, and now we can proceed with writing the answer. Okay, so if the cos of 25 was k, then negative cos 25 means it has to be negative. Okay, exactly, can you see it? Good, well done, very nice. Okay, everybody happy? Making sense? Cool, now we're going to look at the next one. All right, now that's 50. So what is the relationship matrix between 50 and 25? How is 50 related to 25?
It's double, ma'am.
It's double, Emihle, absolutely. So this is a double angle. It's a double angle. Now, when we are working with Pythagoras and when we are working with ratio in terms of the letter, it does not matter which cosine double angle we choose to use. We're going to end up with the same answer. When we choose one of these, when we're working with, when we're choosing cosine double angles and we're working with identities and solving equations, then it matters which one of these we pick. All right, but now here, while we are working with Pythagoras and on the Cartesian plane and ratio in terms of a letter, it doesn't matter which one we pick. All of them will give you the right answer, provided you have substituted incorrectly. Okay, so it's up to you, all right, to decide which one you want to use. I often use 2 cos squared a minus 1. I don't know why, I just seem to like that one, but in reality, all of them will work. Okay, it really doesn't matter. I think in terms of this situation, it's probably going to be easier for us to just work in terms of cos rather than sine, because if we've got sine in our answer, we're going to have to work with this root over here, which is going to be a little bit more difficult for us to do so. All right, so now again, this is where it comes from. Oopsie, wrong pen. Okay, so the cos of 50 is the cos of 2 times 25. You don't have to write this first line. I'm just showing you where it comes from, but you must write this. Okay, so this becomes 2 cos squared 25 minus 1. Be very, very careful. Okay, so this is a square here on the cos. Okay, so it's 2 cos squared 25 minus 1. This comes from our cosine double angle identity. Now I can go ahead and go and substitute in. So I'm going to put in the 2. Cos 25 is k. So when I square it, k needs to be squared. And then I'm going to bring down my minus 1 just like that. Okay, so here matrix, the mark would be on this line. There's always going to be a mark for using the identity. And then there's a mark for writing your answer in terms of k. How do we feel so far? You can give me a thumbs up. Is it making sense to you? Any questions? Thanks, Kanyisile. Thanks, Tabile. Okay, Maite, good. Cool, Lorata. Okay, Pilos and Claire's and Thelma. Nice. Thanks, Letabo. Okay, good. Right, so we've got to expect these things. All right. Cool, Buhle. Thanks, Emihle. All right, now the next one. Okay, in number 3, they want us to calculate the sine of 25. Okay, well, we've actually already done that, to be honest with you. We did it over here when we worked out the value of y in terms of k. So sine 25 is interpreted as y over r. Remember, y was root 1 minus k squared, and that happens to be over 1. You don't have to write that though. I mean the over 1 part. You don't have to write the over 1, because anything over 1, it doesn't change the value of it. Okay, so you can write it if you want to, but you don't have to. And then there we would get a mark for that. And now the last one, number 4, let's just do that quickly. Okay, sine 50. So again, this is quite easy. Sine 50, 50 we know is double 25. So this is the sine double angle identity. All right, and again, we are expected to write it out. We have to expand it. So they would expect us to do this. I'm taking a shortcut here. 2 sine 25 cos 25. Does everybody know where that comes from? Okay, so up here, I'm using my cosine double angle identity. I'm just highlighting it in turquoise at the top of the screen. Again, I have to do that. I have to write that line. They will mark that. And now I can go and sub in. Okay, so this means 2 times the sine of 25 times the cos of 25. And all of those have to be in terms of k. So this means 2 times root 1 minus k squared times k. Now, if you left your answer like that, you would get full marks for it. Absolutely no doubt. But generally speaking, when we've got a surd that's part of our answer and we've got other factors, we normally put the factors together at the front. So I'd write the 2 and the k together, and then I'd write multiplied by 1 minus k squared afterwards. Okay, but if you didn't do that and you left it over here where I put the little purple star, they're not going to mark you down. That would be fine. Okay, so again, a mark for expanding and a mark on the answer. Okay, so that's ratio in terms of a letter. Any questions? No, all good? All right, so then what we're going to do is I'm going to give you guys an opportunity to try one as well. Okay, so the one that you're going to do is just a little bit more difficult than what I did. But I'm here to help you. So if you've got any questions, that's fine. You're going to shout. Okay, so here, the one that I've given you is if the sine of 18 is equal to t, determine the following in terms of t. Okay, so cos 18, sine 78, sine 36, and tan 198. What I am going to go and do, though, is just grab this and I'll pull it down here so that you guys, actually, I shouldn't have moved that up. Let me just put it over here for you. And then you guys have got that right in front of you, and it just makes life a little bit easier. Okay, is that big enough? Can everybody see okay? Just make those a bit bigger. All right. So now Nicole and I are going to be quiet for, you're probably going to need at least 5 minutes to try this. Okay, so, but I'm going to give you the opportunity to work on that. If you've got any questions or you're stuck on anything, please, please don't sit there and be stuck. Speak up. That's why we're here. We're here to help you. Okay, so off you go. Good luck. Yes, Katleho. Okay, so whenever they give you the variable is always written over 1. Absolutely. So sine 18 equals t. T means t over 1. Yes, perfect. Yes, Tisha, this is why we're doing this question, all right? So you don't need to reduce 78. 78 is already an acute angle, all right? And now this is where we have to get creative. We need to make 78 from 18. So the only way that we can do that is to use special angles. And the trick with this one, I was waiting for someone to ask me this question. The trick with this one, Tisha, is this, right? Is to see the sine of 78 as the sine of 60 plus 18. Okay, so that is a sine compound.
Angle.
Exactly. Okay. So that's what I'm saying. You've got to be on the lookout for these things. All right. So when you have some obscure numbers, think about 30 plus, 45 plus, 60 plus, or you can make another number by saying 60 minus or 45 minus or 30 minus. Okay, so be aware of those. But that's what we would do in this case. So we're going to have to use special angles. Yeah, pleasure, pleasure, pleasure. Cool, Lorato, well done. Nice. Okay, so other people should be finishing off soon too, and then we can mark it. Good. Okay, other Loratos also done. Cool, and Jamie, nice, well done. Cool, Tabile. Yes, can you see there for question 4? Okay, so you can see that it's 198. So that first means that you need to reduce. Okay, Void Shepo, cool. Okay, using your normal grade 11 reduction formulae. Okay, and then go from there. Can you see there? Let's just see how everybody's doing. Okay, you also done, Tisha. Okay, so what that means for us, okay, Thelma, you also done. Okay, cool. Can you see that you're done now? All right, not a problem. All right, so in number 1, all right, so the cos of 18, it means you would have had, I think, can you see to put the answer in this for us already, it would have been 1 minus t squared like so. Okay, so here, in this particular case, x would have been equal to root 1 minus t squared, y is equal to t, and r is equal to 1. That's what we would have, the calculations that we would have done. Then when it came to working out the sign of 78, there would definitely have been a mark for this put over here, writing it like that. And then you would have had to expand it using your sine compound angle. So remember, sine keeps its sign. So this is going to end up being sine 60 cos 18 plus cos 60 sine 18. In fact, this is where you probably wouldn't get the mark there. You'd get the mark on this line over here. All right. See, there's another question. Is there a question? Yes. So hang on, just let me just reply to you, Trish. Okay, there we go. All right, so now that we've done that, we're going to use our special angles. And if you learn them off by heart, it just makes it so much easier. You don't have to go backwards and forwards and backwards and forwards. All right, so the sine of 60 is root 3 over 2. Cos 18 is going to be, so this is going to be times, this is going to be root 1 minus t squared. Plus the cos of 60, the cos of 60 is a half, and the sine of 18 is going to be t, just like that. All right, now, if you want to, you can write that under 2 by itself, but you don't need to. If you stop there, you would get full marks for your answer. Okay, so that's absolutely fine. You don't have to write it as one fraction over the same denominator. How did that go? Did you guys get that right?
Ma'am?
Yes.
Ma'am, is it okay if you re-explain number 1? I'm not sure. I don't think I got it.
Okay, so in number 1, you were doing the theorem of Pythagoras. Okay, so in number 1, you would have said they've given you the sine of 18 is t over 1. So if the sine of 18 is t, t is over 1. So that means you've got y over r. So now you're going to do x squared plus y squared equals r squared.
Oh.
Okay, and then you're going to solve for x by taking that over to that side and taking the square root. That's where the 1 minus t squared comes from. Okay, so there would definitely be a mark for you using the identity and then forgetting that. Okay, I just want to have a look in the chat now. Okay, but Shepo's got a nice smiley face. It's a pleasure. Yes, okay, so you guys got that. Lovely, well done. That's great. So that would be considered difficult. Yes, Emihle.
Ma'am, for number 2, what if you got root 3 minus 3t squared plus t over 2?
Okay, just hold on, just read that to me again, Emihle. Root 3
minus 3t squared and then outside plus t over 2.
That's perfect. 100%. You've just expanded your brackets. That's lovely. Well done. Okay, very nice. Okay, 100%. Perfect. Very good. Okay, then again, we look at question number 3. We can see that 36 is double 18. So we write down this has to be the sine double angle identity. So this has to be equal to 2 sine 18 cos 18. We have to write that. Okay, and then we can go ahead and go and sub in. So this is going to be 2 times the sine of 18 is going to be t over 1 times the cos of 18 is going to be times root 1 minus t squared. Okay, so again here for the double angle identity and for subbing in terms of t. And then the last one, number 4. Okay, so some of you may have heard me saying this to Kanyisile, you would have to reduce first of all. Okay, so again, you don't have to write this, but this is where it comes from. Okay, so we would make the tan of 198. We would make that from 180 plus 18. Okay, so that is quadrant 3, where tan theta is positive. So this reduces to positive tan 18. This you would have to write. This you'll get a mark for. Won't get a mark for the first line. And the tan of 18 can be written as y over x. Okay, so that becomes t over root 1 minus t squared, like so. Okay, and then you'd get a mark for that too. Sure, I can explain number 3 again, not a problem. Okay, so in number 3, let me just do number 3 again. Okay, so in number 3, can you see I'll be with you right now, my darling? Unless you're also stuck with number 3. So sine 36 is the sine of 2 times 18. Okay, but you're not going to get a mark for writing that. So this becomes 2 sine 18 cos 18. It is your sine double angle identity. All right, so then you're going to sub in, remember sine 18 was t, and then the cos of 18 was root 1 minus t squared. Okay, all right, Miso, I'm just going to have a look at what you said. I got step 1 more, just stuck on the answer. Okay, so in terms of your answer, you're just substituting. So for tan 18 means y over x. Okay, so here, tan 18, I'll just write it up here. Tan 18 means y over x, but it's y in terms of t over x in terms of t. So we're just subbing in from here. Okay, so y is equal to t and x was equal to root 1 minus t squared. Okay, Miso. Kanyisile, did you have a question? Yes, absolutely. Absolutely, Kanyisile, not a problem. You can do that as well. 100%, no problem at all. Okay, cool, Miso, I'm glad. All right, so that was really nice. Okay, good, well done. So now let's move on and go and have a look. This is more of the same thing, but I think what I'm going to do is I can leave this here and you guys can come back to this and you can try this question on your own. what I think I want to try and do is just sort of move on and do some stuff that's just a little bit more difficult instead of repeating myself with these things that you actually already now know how to do. Okay, so let's have a look at if they gave us a question like this. So these are two separate questions, even though it doesn't look like it. I suppose what we could do is call this one, essentially we'd be on question number 3 by now, wouldn't we? So this one could be question number 3 and this one could be question number 4, all right? This is more problem solving, and I wanted us to be able to spend a little bit of time this lesson discussing these sort of slightly more difficult questions. So number 4 is a little bit more difficult than number 3. In number 3, they tell us if the sine of 9 is equal to k, determine the value of the sine of 18 in terms of k. So given the discussion that we've had and what we know up to this point, it shouldn't be too difficult for us to figure out what's going on here, all right? Does anybody want to tell me what they think we should do for number 3? Cool, can you see? Let's go for it.
So ma'am, we to find the value of sine 18 in terms of k, I would have to say that since 18 is double 9, we'll have to use our double angle formula.
You would, absolutely. All right, perfect. So you spotted that straight away. Okay, so 2 times 9 degrees gives you 18 degrees. And now when we expand it, what should we write here? Can you see, can you tell me what I should write?
2 sine 9. Cos 9.
Cos 9, lovely, good. Right, now, what's the problem? And I use the word problem in inverted commas. There's some information that's missing. What's missing? Can anybody tell me what's missing that's stopping me from answering this question? What's not in, there's something that's not in terms of, okay, the sketch, fine. What's missing? Someone said, ma'am? The y value. Okay, but we've got the y value because sine 9 equals k over 1. So Lorato, we know that the sine of, there we go, the sine of 9 is equal to y over r. So that means we've got k over 1. So we know what y is. What's missing is the x. Yes, Lorato, there we go, perfect, the x value. Okay, so now, how are we going to work out x? We're going to use the theorem of Pythagoras. Okay, so we will come along and we'll say x squared plus y squared equals r squared. So that means that x is going to be equal to root 1 minus k squared, like so. Okay, so now we've got our missing x. So now we can go and sub in 2 times the sine of 9. The sine of 9 is k, and the cos of 9 is 1 minus k squared. Okay, that wasn't so difficult, hey? It's just one question on its own as opposed to a whole lot. Cool, how are you guys feeling? Hopefully you're feeling good and confident. Nice, good, great. Lovely, I'm so glad to hear that. Now, let's go and have a look. Yeah, Pythagoras is nice. Let's go and have a look. Cool, Ryle. Peter, you're also feeling good. Oh, I'm glad to hear it. Okay, let's go and have a look at number 4. So now they've told us if the cos of 55 is p, determine the value of cos 5 in terms of p. What do you guys think we should do here? So the cos of 55 is P. Determine the value of cos 5 in terms of P.
55 minus 45, ma'am.
Okay, but 55 minus
Oh,
45 is 10, but I like the way you're thinking. I really like the way you're thinking. You're on the right track. You're on the right track. Stay there and just change it a little bit. You're on the right track.
Oh,
That's very
60
good.
minus 55, ma'am.
Ah, there we go. You see, look at that.
What's
That's
if-
amazing. You guys got that so fast. I'm super impressed. Absolutely. Okay, so well done. That was Emihle, hey?
Yes, ma'am.
Yes, well done, Emihle, and Thelma, because you also put that into the chat. That's brilliant. Absolutely brilliant that you spotted it. Okay, so can everybody see what Thelma put into the chat or heard what Emihle said? We would be able to make 5 from saying 60 minus 55. So what I'm going to do, now that that answer is there, let you do this by yourselves. I'll go and grab this thingy again and slap it over here. Ooh, what can we do here? Let's just move that one down and that one down. Where can we put it so that it's here but not in the way and visible? Eesh, that doesn't help us. Okay. Sorry guys, these are the challenges with teaching online. Okay, well, we don't need the solution to number 3 to do number 4. So let's pop that over there. Okay, so you guys try number 4 quickly. And if there's anyone who's feeling a little bit stuck and doesn't know where to start, then I'm more than happy to help. But hopefully you saw what Thelma said and heard what Emihle said. They were both correct. Okay, off you go. Cool. Oh, nice. Wow, that was fast. Okay, well done, guys. Nice. A lot of you have done that really, really fast, which is great. Okay, so just to run through it then. So the cos of 5 can be written as the cos of 60 minus 55. We would expand that using our cosine compound angle formulae. Remember, it's cos, and cosine does not keep its sign. All right, now the cos of 60 is 1 over 2. The cos of 55 in this case would be equal to P, plus the sine of 60, that's root 3 over 2, and the sine of 55, in this case, we would have had to do the theorem of Pythagoras, so we would have said that P squared plus Y squared equals R squared, so that means that Y is equal to root 1 minus P squared, and then here we would have had root 1 minus P squared. Whoopsie, that's not written very nicely at all. Let me just fix that. P squared. Okay, that looks much better. Okay, so here we would have had a mark for using our compound angle identity. Definitely a mark for Pythagoras, and then a mark for our answer. Yes, Iazi.
Ma'am, can you please show us how would we have to like factorize it a step further, like just to get it all summed up?
I mean, if you wanted to put it all over the same denominator.
Yes, ma'am.
Okay, all right. So if you wanted to do that, and you really don't have to do that, okay? But if you want to, 1p means p, okay? Plus, what you can do is you can multiply this root 3 into the bracket. So in other words, if you've got root 3 and you're multiplying that by root 1 minus p squared, remember our rule with thirds. So if you've got root 3 and you multiply that by root 2, it's equal to root 6. Okay, so you can do the same thing here where you can expand the 3 to the 1 and the 3 to the p squared, and you can keep the root. So this would be 3 minus 3p squared, and that would all be over 2. Okay, so you can do that if you want to. Not necessary, but you can do that if you want to. Okay, are you guys ready for a nice difficult question? Do you want sort of difficult, or do you want really difficult? How difficult do you want it to be?
Really difficult.
Really difficult. Okay, Tondalweta, I like the way you think. Okay, so let's do it. Okay, so here's this question over here that I've dug out for you guys. This is a really, good. I'm so glad that you guys want to try the really difficult ones. Okay, so here we go. If the sine of 61 is equal to root a, determine the value of cos 15, cos 73 plus sine 15, sine 73 in terms of a. Yes, this is maths. This is maths. And what you're going to do is you're going to start off looking at this immediately. And what do you recognize here? Like, what's one of the pieces of information that they've given you that you can use? I'm highlighting it in blue, boys.
Because compound angle, ma'am.
Exactly, exactly. So start with that, and let's see where exactly, Tabila, let's see where that takes us. All right, now, something I want to point out to you. They've been a little bit sneaky with this question. Can you see how they've written cos 15 and then cos 73, and then sine 15 and then sine 73? So what we're going to do is we're going to switch the cos 15 and the cos 73 around. And we're allowed to do that because a times b is b times a. The order in which we multiply two things doesn't matter. So let's rearrange and write that as the cos of 73, cos 15, plus the sine of 73, the sine of 15. And the reason that I wanted to switch it around, Matrix, is because I can see that I'm going to be using my cosine compound angle. But remember, cos doesn't keep its sign. So there's going to be a minus. So I don't want 15 minus 73 and then have to work with a negative angle. Although I suppose you could if you wanted to, but it's just creating more work for you. This way, I don't have to work with any negative angles. So now that it looks identical to my cosine compound angle formula, remember, like the lock and a key, we can turn backwards, and cosine does not keep its sign. So this is going to be 73 minus 15. And now we're going to end up with 73 minus 15, which is going to give us the cos of
58.
Absolutely. All right. And now we are stumped because we're looking at the sine of 61 equals a. And now we've got the cos of 58 and we're like, wow, really, where is this question taking us? So now we're going to have to be very, very careful, not careful, but creative. We need to know our work super, super, super well. I've got to somehow try and relate the sine of 61. So the angle 61, somehow I've got to relate that to 58. Cassandra, what do you want to say?
Ma'am, can we say 90 minus 61, which is 29, and then 29 times 2, which is 58?
Oh, Cassandra, that was brilliant. Absolutely. Absolutely, you can. Absolutely. And did the rest of you hear what Cassandra was saying? So here, these are connected to one another using a sine, cosine, co-ratio. Does that make sense to everybody? So if you played around on your calculator, all right, and you said 90 minus 61, that would give you 29. And if you take 29 and you times it by 2, so a double angle, you're going to end up with 58. Does that make sense to everybody?
Yes, ma'am.
Okay, all right. So this is the easiest way to do it. All right, this is the easiest way to do it. All right. Because you already know that the sine of 61 is equal to root a, what you can do is you can rewrite the sine of 61 as the cos of 29. Does that make sense? Okay, remember, we were talking about it at the start of these lessons, and you can never forget this. This is so important when you do your compound angles, when you do double angles, is your sine, cosine, co-ratios. So remember, if one is sine and the other one is cosine, and the angles add up to 90, okay, we can write sine as cosine and cosine as sine. Okay, very, very useful, very, very important. Okay, so now we are able to relate the sine of 61 to the cos of 29. And now it's not going to be so difficult for us to write cos 29 in terms of 58. So we know that the cos of 58 is equal to the cos of 2 times 29. So this gives us, and again, it doesn't matter which cosine double angle formula we use. For some reason, I always just go for 2 cos squared 19 minus 1. I seem to like that one for whatever reason. And now we can go ahead and we can go and sub in. So now we're going to write 2, and then the cos of 29 is root a. So we want root a, and we want to square it, minus 1. And that leaves us with 2a minus 1. There we go. All right, so we have worked out the value of cos 15, cos 73, sine 15, sine 73, which is cos 58 in terms of a. How do you guys feel?
Wonderful, ma'am.
Oh, immediately you've made my day. I'm so glad. I'm so glad. Cool, Thelma. Good. Good, good, good. Okay, and I mean, if you can, this is really difficult. So if this is making sense to you and you're following on and you're happy with it, then that's a really, really great sign, because something like this would be considered super, super hard. All right, so I think it's really important. I want to try and do as many problem solving questions with you as we get the opportunity to. It's important that we see stuff like this because it does come up in tests and exams. All right, and then of course you can always, that's wonderful, Kanisile. I'm so pleased. Yeah, you've just got to keep practicing, and I promise you it does eventually all come together and it does make sense. That's great. Yes, Buhle.
If you left your answer as 2, then the bracket square root a, the bracket again squared minus 1, would you still get the marks, or do you have to simplify?
Do you know what, Buhle? I think in this situation, they would probably want you to write it as 2a minus 1. I think, I don't know. I mean, to me, it's a difficult one, you know, because if you've got that far, you really do understand what the question is asking you. The question is not asking you if you know that the square root of a squared is a. I think if this was a test and you were in my class, I think I would give you the marks. And then I would just say to you, just make sure next time you write it as a and not as root a squared. Okay, but yeah, because I mean, if you've got that far, you understand the concept, and that's the most important thing. Okay, pleasure, guys. It's a greatest pleasure. No problem, Mark. Tandalwetu, I'm glad to see your thumbs ups, and Larato as well. Okay, well, unfortunately, I wish our lessons were 2 hours long instead of 1 hour. I really enjoy spending this time with you, and yeah, it makes me so happy that you feel like it's making sense and you're enjoying it. So we've got to do a poll now. So if you could all just take part in that, and then we'll see you again on Thursday. Calling me, Claire. Wonderful. Thank you. Thank you. Yeah, and just be honest. You don't have to worry about anybody's feelings. Be completely honest about how it was for you.
Ma'am.
Yes, Iazi.
On your third step, I think you wrote 19 instead of 29.
Oh, did I make a mistake?
I think so.
Oh, okay. I think Kanisila also told me that, and I was just too busy sitting here thinking I'm so clever. All right, my apologies. Quite right. Sorry, that should be a 29. Thank you, ERZ. Thank you for pointing that out. Kanisila, I think you also told me way back when, and I didn't. Yes, thank you. Thank you. Silly me. Okay, well, as long as you've voted, then you are welcome to go, unless there are other questions. But if not, then we'll see you next time on Thursday. Thank you, Matrix. You are amazing. I hope you have a wonderful Freedom Day, and we'll see you on the other side. Pleasure.